Okay, these are pages 9 and 10 in your fall final take-home test. So really this is the Unit 5 material, thermochemistry. Real quick, this was really helpful for a lot of my students. Endothermic and exothermic abbreviations. Endo, E-N-D-O, is 4 letters. Would feel C-O-L-D, 4 letters. And energy goes I-N-T-O, the reaction. So 4 letters, endo, energy is into it, which means absorbed. It would feel cold to the touch. Exo then, exothermic, EXO, 3 letters, would feel H-O-T, 3 letters, and energy goes O-U-T, 3 letters of the reaction. So an endothermic reaction, energy is going into, that's not releasing. You can't create or destroy energy. If energy is going into it, that's absorbing heat from the surroundings. Exothermic reactions, energy goes out in an exothermic. That's releasing heat. A. Exothermic would feel H-O-T, C-O-L-D, those kinds of things. All right, reading our 3 types of graphs then. This type of graph, we only care about 3 points. The first, the vertex or the highest, and the last points. So for, in this case, I'm starting here, and at the very end I have less energy, which means I have to spend energy. Energy goes out. Whoops, E-N-E-R-G-Y. Energy is going out of this graph, which makes it O-U-T, exothermic. Okay, in my class, for Mrs. Holm, we did this for delta H. Okay, we care about the very first point and the very last point. So my delta H, my change, the triangle, my change in H is it's going down, which would be the negative direction. It's going down by, from 60 down to 50, 10. The H, or the horizontal difference, is down by 10. Activation energy, I told my students, is activating a roller coaster, like that. And it's always A+. So to start my roller coaster right here, I have to go up to the very top, and then I can react. So in this case, it's always positive, A+. I have to go from 60 up to 80 to activate this reaction, which is a difference of 20. I have to go up by 20, my activation. Okay, so again, we only care about 3 points. The first one, which is about 17. Okay, it's not super precise, this graph. The vertex, which is up here at 45. And the final, which is down here at 30. Okay. Overall, it's moving up, which means energy has to be going into it. I-N-T-O is E-N-D-O, endothermic. Energy is going into it. Okay, my horizontal difference as I go from the beginning to the very end is positive. I'm going up, so I'm moving up in the y direction by 17 to 30 is about 13. I'm getting about 13 higher overall. And to activate, okay, so it has to be positive. I have to go from 17 up to 45. So that difference would be 45 minus 17. Okay, about 28. If you said 29 or 26, that's fine. But about 28. Reading this kind of graph, my students know this is the Valzilla graph. If you know that story, awesome. If you don't, I'm sorry. We've got different states here. So I've got solid, liquid, and gas. So as we label this, you're going to label it solid, liquid, gas. So then the 4 arrows that are on there, moving this direction from a liquid to a solid would be freezing. Moving from a solid to a liquid would be melting. Okay, so you should know how to read this. If that doesn't make sense to you, you need to go back and look at the Unit 5 homework, or the Unit 5 homework video for pages 5 and 6. Okay. All right, let's look at the last page. Last page, we've got the third kind of graph, which is called the butt diagram. It's a flat one in this case because there's no curves. And you need to know where solid, liquid, and gaseous states are. So remember, at low temperatures, here on the x-axis, let me try that again. When I'm low temperatures, most of the time we'd be considered solids. Okay. Also, we're going to take a look over here for which is the next state. So looking at the other states, the state that's most common at high temperatures would be this one, gases. So it's always solid, liquid, gas. Okay, so I've done those 3. Question 14 is asking you to circle the triple point. The triple point is where all 3 lines meet. Now, technically, this is a graph of 3 different lines. Okay, so from the triple point, we've got this line, I use all my pretty colors. This line and this line. Okay, so where the 3 points intersect is called the triple point. That's where you could exist as solid, liquid, or gas, at that combination of pressure and temperature. So if this pink line is the border between solids and liquids, then really what this pink line represents is freezing or melting. Okay, if I'm moving this way, I'm freezing. If I'm moving this way, I'm melting. The border between liquids and gases, this blue line represents evaporating or condensing. And then the weird ones between solids and gases, this green line represents sublimation or deposition. Okay. So at question 15 it says, what is the freezing point at 1 atmosphere of the substance? So atmosphere is on this axis, the y-axis. So 1 atmosphere, I'm going to go ahead and just make a note of that. Freezing point, where is it freezing? The border between solids and liquids, right there, is where it freezes at that pressure. So if we come straight down, it's right about 101 or whatever, you can just say 100 degrees Celsius. That's where it freezes at that pressure. Okay, if you double the pressure, then it freezes at a higher temperature. So we can kind of look at that. But here, that's where we're looking. The pressure of the triple point, 16, they're asking me to read the y-axis. So the pressure of the triple points is like halfway between. So 0.6 or 0.62, right around in there approximately. Approximation. Approximately. Temperature of the triple point then. We will come straight down. It looks like it's about 95. You could say 100 degrees Celsius too. That's right around there. Okay, now let's take a look at this one. It says, assume a substance is at 1 atmosphere, or 1.5 atmospheres. So it'd be right about here, and 0 degrees. So if I plot that point, it'd be right there. If the pressure was lowered to 0.25, so if I move it down to here, what phase change is occurring? Well, then my dot moves from a solid down to a gas. Okay, and going from a solid to a gas is the weird phase change called sublimation. That'd be like dry ice. Okay, even at the same temperature, if you remove pressure, then it's able to turn into a gas. If this felt like, whoa, that's confusing, then you need to go back and look at the Unit 5 homework again, or the Unit 5 homework videos. All right, good job, y'all.